Hello chemistry scholars, a quick tutorial here using dimensional analysis to solve mole problems. So for starters, let's see, we've got our little mole. This will be our mascot throughout the tutorial. Mascot for good luck. Alright, so let's first start with a discussion about what a mole is. Mole in chemistry is used to count. Remember, atoms are so small, they're difficult to count, so we count by weighing. Thanks to guys like Avogadro and other scientists that have come before us, we've learned that in 12 grams of carbon, here's my pile of carbon right here, a little pile of carbon in a weigh boat. No, that's not a sombrero. So here's right here is my carbon. This is my weigh boat. Remember, this is our mole, our mascot mole. Let's go back to my pen here. So in these 12 grams of carbon, we have 6.022 times 10 to 23 atoms. It's a lot of atoms in a small sample there. That sample has a mass of 12 grams. We call this sample 1 mole of carbon atoms. Okay, so let's take another look at our carbon here. There's our pile of carbon. In our weigh boat, remember, we have 12 grams. Let me change that up. 12 grams of carbon here. In our weigh boat, we said that that was 1 mole of carbon. Well, what if we have, say, 91.3 grams of carbon, or 0.0015 grams of carbon? How many moles do we have? How many moles do we have there? If we have, let's get a laser pointer here, 91.3 grams of carbon, how many moles of carbon do we have? If we have 0.0015 grams of carbon, how many moles do we have? We know that we have, in a sample of 12 grams, or a 12 gram sample of carbon, we have 1 mole of carbon. So we need to use dimensional analysis. Dimensional analysis. That's fancy for converting between units. Okay? Dimensional analysis is fancy for converting between units, just like we would convert between centimeters and feet, or feet and meters. Remember, a conversion does not involve changing the value. A conversion is just that. It's a math process that we call dimensional analysis that converts the units of a value. In this case, we're converting grams to moles, or that's what we're going to do next. We're going to convert grams to moles. Alrighty, let's solve this problem here. First, for good luck, we're going to bring back our mole. Moly. Here we go. Alright, we got this problem here where we have 91.3 grams of carbon and we want to convert that using dimensional analysis to moles. How many moles do we have present when we have 91.3 grams of carbon? Let me change up the color here. My pen, a little light. Okay, so as we always do in dimensional analysis problems, we begin by writing down the given value. Okay, let's go ahead and run the picket fence here. We are converting to moles, so moles go on top. Okay, we are converting from grams, so grams go on bottom because we want to cancel the grams. Okay, now we have to write in our equivalencies. Okay, that is to say, how many grams are in a mole of carbon? Well, we figured that out on the last slide. And generally, we're going to have a 1 either in the numerator or the denominator. And the 1's going to go up here. So in 1 mole of carbon, how many grams of carbon do we have? Now what we're going to do is take the value off the periodic table, the atomic mass value off the periodic table, and round to the 100ths. And if you look closely at your periodic tables and you round to 100ths, the 100ths place, the atomic mass, the average atomic mass of carbon is 12.01. Okay, a lot of you might have said to yourself from the get-go that, hey, what we need to do is divide 91.3 grams of carbon by 12 grams, 12.01 grams of carbon to get our answer. Well, this is why you were thinking divide from the get-go. This equivalency right here is what was telling you to divide. Now we've used dimensional analysis to illustrate that thought process. So let me get my pen back here. And keeping our equations nice and neat, what I'm going to do is use my calculator to figure out the answer here. And I'll start by writing out the whole decimal. Okay, so if I divide 91.3 divided by, if I divide 91.3 by 12.01, I'm going to get 7.60199833. Okay, so here's my decimal. Here's my answer written on a fresh page. So let's work with this. And you may be thinking that I've got a number here without any units, and that's not correct. And you would be correct. The units here are moles. Okay, you might also remember that the original value that we were converting is 91.3 grams of carbon. Okay, that has 3 significant digits. So what I need to do is round my answer to 3 significant digits. So I need to round to that 0. And of course the 1 leaves the 0 a 0. So what I'll do is scoot down the page here a little bit. Rewrite my answer and round it to 3 significant digits, 7.60. And of course I need to write in my units. And there's my answer. And of course what I have now is a happy mole. Good job, everybody.